So the lesson gravitation continues, children. Yes, it's still available. Okay, no problem. It should have been 10, I believe. So all this was done. Okay. Now, so when I have 2 point masses, M1, M2 here, at a distance r from it, we say potential energy U equals, the way we derived it, minus G M1 M2 by R. What does it mean? What is the physical significance of this? For understanding it properly, think that this M1 is like Earth. Because if I put M1, M2 alone, you may not completely understand it. I'll put in the place of M1 Earth like this, whose mass is M. This is Earth, children. Radius of this is R. And you know, for all extant points, Earth can be treated as a point mass at the center. What do you mean by for all extant points? To consider the force on a body at an extant point, we can treat this as a point mass at the center. That was what previously we thought. Now, at a distance r from the center, if I have got another mass m, we say that actually we can say that the system has so much energy, but in this particular case, since this is almost fixed in the sense this is not going to move, even this m moves under the attraction of this. So I can say that the potential energy of the mass m is minus G m by r. What does it mean? You need to apply our definition and check it. What it means is, it is bound to the attraction of the Earth with so much energy. It's at rest, you think. So, if somebody puts some kinetic energy into this, which is equal to Gmm by R, so this much energy you put into this, it will go to infinity. It will escape from the influence of Earth. And therefore, this velocity people call as escape velocity. If I take out this m, we get that VE equals 2Gm by R under root, or 2Gm by R plus H under root. So this is the meaning of that minus Gm and M2 by R. This is not R square, children. This is R. I told R, but I wrote R square there. Tell me. Now connect it up with the definition and ask me something. Potential energy of mass m is so much, minus sign. Minus the sign indicates this is an attractive force, and the body is bound to the attraction of Earth by so much energy. Look, the way we got minus gm(m)2 by r is by considering potential energy at infinity as 0. U2 equals 0 here. You just go for the derivation we did previously. When I said potential energy at infinity is 0 and at some point below infinity is minus gmm by r, it means to say that it is falling short of gmm by r energy to go to infinity. It is falling short of gmm by r to go to infinity. Do you follow? Therefore, if I supply that energy by throwing it like that, with a kinetic energy which is just equal to gmm by r, it's going to go away to infinity. And I told you already, this is called escape velocity. So the minus sign indicates that it is bound. Tell me now.
Yesterday, we said when we hold the block in our hand and give nx energy, if that is equal to mg. So here, it's the same, almost the same thing.
Yeah. There's a difference between that and this. I'll show you that. There, we took the potential energy to be 0 at ground.
Yes, here at infinity, we are taking
infinity, we took it as.
That is.
Yes. This one, the way we derived it, r equals 0 was here, but u2 is 0 at infinity. Somewhere I wrote, where is it? Here. So that's the difference. This is a little confusing thing. That's the reason I was asking you to say something.
Yes.
That's what I mean by the feedback. Like someone is twisting your arm. You'll say, no, it is hurting. Stop it, we'll say, right? There should be a feedback. Accordingly, I can speak. If people want only formulas, some equations, we can still manage. It's not a big deal. But if you have to really, why? No, you may ask, why to understand? Only if you understand in physics, your effectiveness of doing problems will be increasing. Otherwise, you should go on doing problems again and again and again and catch some kind of rules which may not be based on the concept, but some kind of ad hoc rules people follow. If it is this way, put this way. If it is that, put this way. Many things people follow, and even good students do mistakes because of that. So, look, when you said it is falling short of this much energy, what do you mean by that actually? Why is it falling short of this energy? You tell me. I just came backwards actually. I took the formula and trying to explain it. If I have to throw it away so that it is not going to be in the field of this, I should provide this much kinetic energy I told you. Do you understand? That if you follow, I can continue. But in the very first place, we did some mathematics there and got this minus gm by r. You can as well write escape velocity as a heading here. I have no problem. Because you can say that I've done it as an application of the potential, gravitational potential energy. Tell me, children. But in the very first place, what do we mean by minus gmm by r? You need to go to the definition of potential energy there. Karthav, you came in late. I was asking this question. Of course, I talked so much already. I took this escape velocity as an application of this potential energy formula. If a body is at a distance r from the center of the earth, it is supposed to be having minus gm by r potential energy. Here I'm saying the body has minus gm by r, though in fact earth and body system should have that energy. But since when I'm throwing it, I'm giving it the velocity to this, and this is moving away and this is not moving, I'm saying it is a potential energy of this mass alone. See, if I throw if earth moves, then this potential energy will be shared. The potential energy sharing will be happening by both of them. So that will come back later. But right now, when he said it has got minus gm by r potential energy in this body here, it means that it is bound to the attraction of the earth by so much energy. Because I took u2 equals 0 here. It means it is falling short of so much energy to go to infinity. I provided that energy in the form of kinetic energy. And I call this VE as VSK because once I provide a kinetic energy which is just equal to plus gm by r, I'm making the energy of this 0. Isn't it? I told you already. 0 energy will be there for what? Parabolic path in that initial conditions I mentioned some time ago.
So minus gmm by r work is being done on the body by gravitational force to keep it in the field.
At least you started something. Others were not saying anything. To keep it in the field, what do you mean by minus gm by r work is done?
So
the body may be at infinity first. As it entered the gravitational field, gravitational force is increasing the speed of it. No, it does positive work. So why do you get minus sign here?
because we said u2 will be 0.
The kinetic energy of the body will increase, no?
Yes, sir.
So how did the kinetic energy increase? By potential energy decreasing. So from 0 to the potential energy decreased to what?
Minus gmm by r. And in order to bring it back to 0, so it will go to infinity.
We should do
plus gmm by r work on
work
that.
in the form of giving
Kinetic energy.
Kinetic energy. That's not a bad thing. And if you want to put it in another way, look, go to our definition. U2 minus U1 equals minus W122 by gravitational force we told.
Yes, sir.
Right? So as the body is moving, U2 minus U1, this is 0 minus UR is equal to minus R to infinity by what? Gravitational force. Isn't it? The way you wrote U2 minus U1 equals minus 1 to 2. 1 is R at distance. So what do I get now? U at R equals W R to infinity. Isn't it so?
Yes.
By gravitation. Right. So look, the body is here. I want to know how much potential energy does it have. So it is equal to the work done by the gravitational force in taking it from R to infinity. But the problem is the body is here. So I would like to write like this: U at R equals instead of this U at R equals, you will write minus W infinity to r.
Yes.
So now look at it. The body was initially at infinity. As it is coming towards the earth, gravity force was acting this way, right?
Yes.
And it is doing a positive work because it is increasing the speed of the body. That would be
Yes,
gmm by r, and negative of that is the potential energy. Look at this. So when you said minus gmm by r, this is the meaning of potential energy there. The body could have been at infinity first, we don't know. As it was brought to infinity, means somebody is bringing it from infinity, you can say, but for a while I'll just move it aside because you'll get confused. As the body is coming towards the center of the earth, until this point, gravity does positive work, isn't it so? Tell me.
Yes, sir. Kinetic energy will increase.
So gravity is doing positive work, right? That work is
Yes.
gmm by r. That work is gmm by r, but negative of that is potential energy. But how do you bring this body? Tell me. Here, who is bringing? I did not tell. Do you follow? Who is bringing? I did not tell. Hello, do you follow my point?
Yes.
As the body is coming, I told. So somebody takes the body in the hand and keeps walking. Gravity will be pulling it away. So he should apply a force in the opposite direction to make it go with a constant speed so that the kinetic energy is not going to increase. That means if the gravity is increasing the speed, he is trying to decrease the speed. If the gravity is doing positive work, he is doing negative work. Therefore, it is minus gmm by r. So in whatever way you say, that will come from the definition only, basically. So can I continue?
So at that point, the gravitational force will be doing plus gmm by r, kinetic energy will be there. So with the negative of that, it can go back to infinity.
Only she is talking, others are not talking anyway. u2 minus u1 is minus 1 to 2 by gravitational force when we wrote. I already told you at infinity you put 0. All this I showed you. So this is the final thing I've mentioned it here.
Yes,
U at r equals negative the work done by gravity as it comes from infinity to this point. But it is positive the work done by the external force if it is brought from infinity to here. So that is coming out to be minus gm by r. As the body is being brought from infinity to here, the person is doing negative work. So that itself is potential energy. How about Aryan and others?
Yes.
Distance r, we say u at r is minus gmm by r. So many ways we can put the wording here. You will think this is essentially at rest. That condition should be there. That means the body is moving, but the earth is not moving. So one way is this. As the body is coming from infinity to r, gravitational force does what work?
Positive.
Does positive work. Why?
Kinetic energy increases.
Work of how much? GMM by R. So potential energy will be minus GMM by R. Second thing, if you think the body is being brought by an external agent, if you think the body is being brought by, tell me, an external agent.
The work done by that agent will be the potential energy.
But work done by that just exactly against gravitational force only is this.
Yes.
He may be doing work against something else also, by an external agent. The work done by the external agent against gravity is what? Minus GM by R. That is potential energy. What I was trying to tell you was, if it is put in terms of the work done by the external agent from infinity to this point, it is just same as the work done by the external agent. But if it is put in terms of the work done by the gravitational force, it is negative of that. So that's coming out very clearly from here. Okay.
Yes.
And look, if the person bringing it from infinity to this point is doing this much work, how much work he should do to throw it away?
Same.
Plus. Same, but plus.
Negative.
Isn't it so? All right. Hello, Aryan, Balavardhan, Vamshi, all of you tell me. So this has to be understood. Why I'll tell you. Just write it. I'll come back to an application. Instead of telling you again and again without any response from you, I'll give an application there straight away. So this minus GM by R is interpreted in many ways. Interpreted in many ways means I did not do the other way. Now what it means is, it implies that, tell me, it implies what? The external agent should work, tell me, by what? GMM by R to throw it to infinity. There's another way.
Yes, so from R, that much work.
Because he did a work of minus GM by R in bringing it from infinity to R. Gravity was doing positive work. Negative of that is potential energy. Anytime it is like that. Work done by the conservative force you calculate in moving it from one place to another place. Negative of that will be potential energy. Every time. Look at this. The spring mass system, if I have, if I pulled it through a distance x by holding it by my hand, how much work is done by the spring force?
Yes.
Work by spring force.
Half kx.
Minus half kx square, not half kx square. Why? X is this way, kx is acting that way. So it is minus half kx square. So potential energy is, or what work is done by me against kx? Work done by external will be what? Plus. So potential energy, that is equal to potential energy. So in terms of work done by the external force, it is directly the work done by the external force. Remember it. But in terms of the conservative force, is the negative of the work done by the conservative force. So that way, it's not so tricky. Hmm?
Sir, in the first point, second line.
If the body is coming from infinity to R, gravitational force does positive work of Gm by R. So UR is minus Gm by R.
Yes.
Tell me, Aryan. Children, this keeps coming everywhere from now onwards. Okay, I'll keep coming back to the same thing again and again. But somewhere you should say, sir, we followed it. Right. So can I continue? I've given the example here immediately. Thumb rule, like if you are, what is potential energy? If somebody says it is negative of the work done by the conservative force or positive of the work done by the external force against gravity alone. That way you should say, otherwise you should say external force with a constant speed. Because this part I'm scared of explaining it again and again. Because people wouldn't leave me previously. They go on discussing it. But here I'm talking to myself all the time. Okay. It's not difficult actually. I mean, like by not responding, you are making it look difficult, and it's frustrating for me. Got Vaishnavi M.
Yes, sir.
No, because I'm going on talking and talking and talking. I could have finished it long ago. You don't know. Huh? I'll continue. I'll give a problem and then we'll see. Look. There's a system like this, for example. Comparable masses instead of, I'll just give this only, no problem. The distance is R. Remember, they're not free. If they're free, they still keep moving towards each other, right? They are fixed. That means they are held by some other force. You follow? Huh? What is the work required? What amount of work required? What amount of work is required to deassemble the system or to throw the particles to infinity? Particles up to infinity. Now, what work is required means what? What work should somebody do to throw them up to infinity? Isn't it? Huh? It implies work done by external force is equal to how much? How much is that? Simply tell me. Tell me. Size there.
GMM by R.
That's all. That's enough. Since U is minus, what it means is the external fellow must have worked by so much in putting them like this. So now you work so much to throw them away. This implies what? It it implies that the external agent must have worked by how much? Minus to bring them where?
Infinity to
From infinity and place them at r from each other. Against gravity. So that's the meaning of, that's a direct application I'm giving you now. Tell me, Kartham. So that U equals minus GM2 by R is straight away is the work done by the external agent. Okay. Or it is the work done by the gravity with a negative sign in bringing the masses from infinity to that configuration. So I think I gave you the final words after all that discussion. Pavani, do you follow?
Yes, sir.
Really?
Yes, sir.
Can I continue then?
Yes.
Tell me, children, should I continue?
Yes.
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 Any questions you have? Any questions you have? You don't have. All right. We'll see. Now, the gravitational potential energy of a system of point masses. A system of many point masses. Okay. First, for 2 we wrote. For 3, how shall we write? A simple trick I will tell you for this without bothering you much. If the distance is r like that, U of the system, you can simply write the potential energy of every pair of charge, that is minus G M1 N2 by R plus minus G M1 M3 by R plus minus G M2. That's all. First these two, then we wrote these two, then we wrote these two. That's all. That will be the total system's potential energy. If M1 equals M2 equals M, what do I get? U of the system equals minus 3 gm square by r. Do you follow? Which implies we require to do a work of what? Plus 3gm square by r to throw them up to infinite. But situation is different if they are moving.
Sir, up to infinity, meaning all three of them
Will
be
go, they won't be under their attractive force.
their individual paths.
Yeah. Individual particles will be going away. All of them we throw, not one.
Yes.
In other words, you are deassembling the system completely. What is it? To deassemble the system. Okay. But for example, they're all exam questions. That way you will be motivated actually, I don't know. Or you will be motivated only with ABCDs. Huh? Now, the center of the circle, each is M. They are going in a circular path like this. This side length of each, this is R. So, what is the energy required to deassemble the system here? Energy required to deassemble the system here. Tell me. Then I can say, actually, now look, you may not be able to do it for a simple reason that the original meaning of what we're talking was not followed probably. Here, did I say the particles are moving? No. But here the particles are moving. So, okay, I'll ask you.
Sir, do we need to consider kinetic energy?
I cannot hear.
Sir, do we need to consider kinetic energy?
Do we need to consider? Tell me, do we need to consider what? Kartav, tell me. First of all, tell me, do we require more energy here or here to deassemble? Do we require more energy in this case or in this case? This is what you mean by ideas. Look, they were all at rest initially. So we required so much energy to move them away from each other. But how do you move them away from each other? By giving them velocities, right? Huh? Hello. You will stand here, you will stand there, you will stand here, or you will stand and hold both of them. And this fellow will stand and throw them away like that. Tell me. That can be done in many ways, but the total energy will be that. But here they already have velocities. So you require to provide some more velocity so that they go away. So here you require less energy. You can see it if you want. You get the velocity of each particle. If this is R, this will be how much, children? If this is R, this will be how much?
Root 3.
R by root 3. So mv square by R equals what is the force on each one particle due to the other two? Root 3 gm square by R square, isn't it?
Yes.
I don't know whether people understood it. So what do we get now for the velocity? Huh? 1 m goes, right? Tell me, children. Root 3 goes, isn't it? Huh?
Yes.
And 1 r goes. So v square equals how much do I get? Tell me.
Root
GM by R.
Root GM by R.
Is the calculation right, children? Huh?
Yes.
Check it.
Yes, sir.
So half mv square if it equals how much? G m square by 2r. Am I correct? Hello. Multiplied with half and both the sides, nothing else.
Yes.
Yes.
So the kinetic energy of 3 masses will be how much? 3 by 2. G m square by r. And potential energy was how much? So much. Right? So the total energy will be now, this is minus sign, of course. Minus 3 g m square by r. So the total energy, which you call as binding energy, will be minus 3 by 2 gm square by r. So if you have to throw them up to infinity, the total energy you need to provide is given by this. How much that? How much is that? Plus 3 by 2 gm square by r. Whereas it was gm square by r here, whereas it is 3 by 2 gm square by r. So you are providing less energy because already the bodies were having kinetic energy. So I'm putting your escape velocity, orbital velocity, that kind of thing in a very general, meaningful form here. Tell me, Karto. See, now if you did not follow what I was
Sir.
speaking, now it will be trouble. Tell me. There's a system going like that. I want just all of them to be going to infinity without influencing the other. The total energy I need to provide for this system is so much, which is half of this one. This one is required when they were at rest, but this one is required when they are moving like that in a circular path. And this energy, total energy, will be called E binding. Even this has come as a minus sign because the potential energy is more in magnitude than the kinetic energy. So should I believe that you followed this? Kartav, tell me. Hello. The whole maths I've done. Just look at it carefully and tell me. This is valid everywhere, children. When I had at a height h, potential energy is mgh. It is a work done by external force in moving it from 0 to h. When a person moves it up, he'll do positive work. It is also equal to negative the work done by the mg. While going up, mg will do minus mgh work, negative that is potential energy. So you come in various ways, you'll end up with that statement. Tell me now. Tilak, Vamshi, Trishul.
Yes, sir.
You decided not to speak. I'm telling you finally the tricks also. No, what is the trouble? Vamshi, what is happening to you?
Yes.
If it is S, I'll give you a question, first of all. Can I go to the next page?
Yes.
I'm going. Now, tell me the gravitational potential energy of a system of masses like this, first of all. And comment on the result. They are at the vertices of a square of side M. So my question is, U of the system is how much? Come on. After that, comment on the result. And when I said they are situated there, they're not moving. Okay?
6 gm square by A.
Tell me, Sudhir.
6 gm square by A.
6 gm square by
A.
A. A good attempt. At least he was now talking, but the answer is not correct. First of all, Sudhir, it cannot have a positive sign. Gravitational potential energy cannot have a positive sign. That's the first mistake. At least we have told is minus 6 gm square by A.
Yes.
But even that is wrong. It is minus 4 gm square by A plus minus 2 gm square by root 2A. Tell me. Why? These two pairs, this pair is gm square by A into 4 with a minus sign. These two pairs, they are a distance of what? Root 2A.
Root 2.
So you need to find out every pair and write the potential energy and add up. Even to elaborate that, I'm once again worried because too many things at the same time. When there's no what you call integration. Digitalized information you're remembering, but integration is becoming a problem. So this is the answer for that. And what it means is, to deassemble this configuration, somebody has to do so much work. I can show you that in many ways if you want to do. But all that elaboration actually should not confuse people. So you want me to continue? You know why this is 4 and this is 2 like this? Hello?
Yes, sir.
Hello, children. To deassemble the combination, we need to do so much work. When I told, I'll tell you what it means. Now, 1 year, more than 1 year, I've been teaching physics to you people. Now, how that may have been achieved, let us think. There are 4 masses already like this. I'll stand here and throw this away from here to infinity. How much work will I do? You tell me.
Minus 4 gm square by 1. Minus 2.
This work, I'll throwing it away to infinity. How much work I'll do on this? Tell me.
minus 4 gm square by m minus 2 gm square. As it is.
This is the work done to deassemble all the masses. W1, I'm talking about this first one.
Yes.
This is the second one. This is the third one. Probably this is the fourth one. So I'll throw the first one out. So how much work will I do? Which is equal to potential energy of this only. That is this one minus g m square by a minus gm square by a minus gm square by root 2a work I'll do. Though this has gone. Now I'll throw this out. W2. That will be minus gm square by a minus, tell me.
gm square by
root 2a. Now this is gone. Now only this has to be thrown out. How much is it? Minus gm square by a. That's all. So count now. 2, 3, 4, 2. The total work is W1 plus W2 plus W3. Now why am I not talking about 4?
Naturally, it will be.
There is nothing else, right?
Yes.
So they have already gone to infinity. So it is equivalent to separating it. You need not have to separate it once again. So is that coming out to be so much? Tell me.
Yes, sir.
Because that was a work done to assemble them. You know how? There was
From
nothing here.
infinity to R, an external
There was
agent.
nothing here. There was nothing here. I brought the first mass. No work. Second mass. That is minus g m square by a.
A.
Third mass. Minus gm square by a into 2. Is it? No.
2 won't be there.
2 won't be there. Minus gm square by
Root 2.
root 2a. Fourth mass. Minus gm square by a into what? 2 minus gm square by, add up, you'll get that. You need not to bring them one after the other. You can, 4 people can keep bringing them together. Even then you'll do the same work. 4 people can throw them away from each other. Even then the same work is done. So that is the meaning of potential energy. Tell me. No, once it is done, if you say, yeah, yes, this I understood, it should have been like this only, what else? I was seriously not thinking previously. That kind of feeling, if you get, it will remain, otherwise it will go away. I'm actually telling you a few rules only. Here and there I'm elaborating. Tell me now. Hello.
Yes.
But now I'll ask you a question. Kartho, are you there? You're not saying anything. When I'm calling Kartho, you're not saying anything. I don't know. We've got 2 formulas actually. I'll be worried if it was me. Look, there's a mass m here. We said here potential energy is mgh. Now we said the earth is not flat like this. We said earth is a sphere. Huh? Hello.
Yes.
So if it is at a height h like this, if this is r, if this is m, we said u equals minus gmm by r plus a. So, but of course, in this case, u equals 0 was taken there. Here in this case, u equals 0 is taken here. So how do you reconcile between the two? That should bother you, basically. Tell me. two formulas we've got.
But in the flat one, we're writing it in terms of acceleration due to gravity.
So you mean to say even that is the same thing as this?
Sir, but here we're taking it to be constant, whereas in the
That
cases
you are just only telling what is already there. Is there any equivalence between them? Are they completely different? When I said how do you reconcile means what? You should justify these two things by connecting them, not by separately telling them, because we already have told them separately.
yes.
Right? So whether one will become the other with particular with a relevant substitution of something or the other. Tell me.
So G we can write as small g, we can write as capital G m by r plus h.
Okay, I'll write m into g as we are writing as gm by r plus h whole square into h. So
we compare it to a negative sign.
You compared it. Are they looking same?
Yes. No.
They are not looking same, right? I wrote it like this. The place of small g, we wrote gm by r plus h whole square. So gmm by r plus h whole square into h, it is coming. So what should I do? Sriya?
So if h is very big,
H is very small here. You're trying to tell something like that. So it will be r square by h square plus 1 whole square. R by h, I'm sorry. No, just a minute. I'm just trying from what you're doing. What I would do is I'll bring this h down here and take it inside. What will it become?
r square by h square plus 1 by h.
This one?
Yes.
So what does it become?
R plus h whole square, and then h power 4 we can take it.
So what is that I'm getting from here? Should I write h or h square?
Sir, root h, sir.
Tell me.
Under root of h, sir. If we take it inside.
Come on, you tell me, what is that happening? I just followed you. I was just suggesting something. Tell me. All right, think about it. We'll come back tomorrow again. But anyway, the whatever problems are given, just focus on them and tell me. I'm ending the show now. Bye. Thank you.
Thank you.